Hello, everyone. I'm George Jackson, Director of Events at GovExec, and welcome to our next session, 5 Key Drivers of JADC2, presented by our Tech 365 underwriter, Leidos. This fireside chat will explore why it's critical for the U.S. military to ensure resilience and achieve a distributed kill chain that shortens the decision cycle and maintains competitive advantage. Joining me, a trio of experts: Erik King, Senior Solutions Architect and Vice President at Leidos; Doug Jones, their Senior Vice President and Defense Group Chief Technology Officer; and Derrick, Director of their Digital Modernization Accelerator. Gentlemen, welcome. Without further ado, let's dive right in. Erik, Leidos works on a broad range of U.S. federal and international customers towards goals of making the world a safer, healthier, more efficient place through IT, engineering, and science. A significant portion of your business supports the Department of Defense, the Joint Services, and the intelligence community through developing, integrating, and delivering technology-driven solutions. How does that align with JADC2?
Well, first off, thanks for having me, George. Appreciate the question. And fundamentally, we start by just recognizing what drives JADC2. We talk to our customers. We look at the technology that's surfacing, and we find that there's basically 5 key drivers or challenges that are propelling this forward. And we try to keep those in mind anytime we're looking at new engagements that are surrounding the JADC2 ecosystem, if you will. The first one is around, not surprisingly, around effective multi-domain operations, recognizing that systems of the past that were built generally around platforms and were service-centric now need to interoperate with one another through interfaces and open architectures that allow them to securely exchange information, and the mission threads that then tie those operations together. The second area is recognizing that the military Internet of Things has kind of arrived. 15 years ago, we couldn't really, we could conceive of it and the technology was there, but now over the last several years, the maturity of the technology to really allow the price of sensors and the accumulation of data to become so prevalent in our world. So understanding that we're going to have a lot more data. We're going to need to collect that data, store it, secure it, and then ultimately make sense of that data to inform the decision-making process is key. The third area is in autonomy and automation. Autonomous platforms have proliferated, whether you're talking about air, sea, ground, et cetera, and then AI, ML in the form of automation. So a lot of processes that were done in the past through human means are now getting automated in unique ways that I think will help the warfighter. And it will also speed up the process of transition. The fourth area is in shrinking the OODA loop. Fundamentally, this is about finding ways iteratively, whether in the sensing side, on the processing side, or the decision-making side, finding small areas where you can decrease the amount of time that it takes to execute those. This can be in the form of doing automated tagging of data, or again, looking at human processes where you can eliminate and streamline those. And then the last area is what we call trusted and resilient systems. And there's really 3 parts to that. One is in the area of cyber, which is becoming more and more important as time goes on, as all this is networked together. The second is in artificial intelligence, making sure that the algorithms that we create are spoof-proof, if you will. And then lastly, in the area of just fundamentally making sure that we have EW protection. So as we work in a contested environment, that those systems are protected and are basically hardened in a way that they can't be penetrated. So those 3 areas together combined formulate what we call trusted systems. So every engagement that we look at, we try to look at through the lens of these 5 areas.
Doug, I saw you nodding your head enthusiastically while Erik was making one of those points in there. What stood out to you?
I think a key one is that shrinking the OODA loop, right? Where you have to observe, orient, decide, and act, right? So this is all about the warfighter to be able to make decisions at speed. And one of the key things we really try to think about when we do this is we can't just build for this mythical future where everything works nicely together. We've got legacy systems. We have to be able to do that incrementally, like Eric said. We got to improve the ability of the warfighter today, tomorrow, and for the future. So that's where we look at how do we spiral down that OODA loop incrementally over time, finding those areas where we can shrink down the timeline that could be the difference between life and death to make those informed decisions, but doing it not just build a system for 15 years from now, but do it that we are improving tomorrow and spiraling down forward.
So Derrick, how does that apply to JADC2, the OODA loop specifically?
Sure. Thanks for having me again. At the most basic level, the concept of JADC2 really revolves around the ability to break silos between data, mission applications, and people who need advanced capabilities to make command and battlefield decisions. The challenge here is that we have created what I would like to call silos of excellence between our warfighter capabilities, whether that be sensor platforms or data collection applications or even weapon systems or cyber effects. So, it really starts with making sure that the infrastructure across the force is sound and is able to handle, the volume and speed upon which data needs to be exchanged across multiple security layers. And right now, pretty much all of the Army, the Navy, the Air Force, these environments are very much heterogeneous. So the mandate here is for us to be able to have resilient and redundant networks. From space down to the terrestrial layers, think about land, at sea. And then from a multi-domain operations standpoint, it's critical for us to be able to leverage existing platforms in new ways so we can, switch from one network to another. If one network goes down, how do you switch to another so you can still do distributed command and control, which we need to facilitate faster decisions. So I'll just give a quick example, which relates to sort of sensor to shooter capabilities, which are gaining a lot of steam and attraction in view of the emerging threats in Asia. So, having interoperability across our data repositories, our sensors, our applications, it's really designed to increase the velocity of decision-making in the battle space. And that's what the OODA loop is about. We've entered into a time of great power competition. And one of the core functions of JADC2 is to decrease the time it takes from sensing an enemy threat, then moving to confirming the validity of a target, and then eliminating it. So we have to be able to do this faster than our adversaries. So these processes need to take seconds or minutes, vice 20 or 30 minutes. So this is the OODA loop that we're talking about. How fast can we sense a threat and then eliminate it? So I think it's really critical for industry and the government to work in concert to confront this challenge, because the JADC2 concept is really not achievable unless we're able to connect the dots between our data, our platforms, our sensors, and our people across the entire force.
And relevance at the highest levels. I mean, President Biden was talking about this at the G7 summit just earlier this month. Doug, let's move to autonomy and automation. Eric raised this point during his opening remarks. It's a hot topic nationwide, from everything from autonomous vehicles to pizza delivery to drones coming at you from Amazon. But how does it apply to JADC2, something much more serious than those? And where does trust come into that discussion?
Thanks, George. Honestly, we see it every day in our lives, right? But when you get into life critical situations and you start talking around trust, it's absolutely critical. When you think about the US military, it is the most effective fighting force in the world. And a lot of that is built upon trust. When they take soldiers through basic training, they talk about how you trust your platoon or your supporting soldiers, right? How do they trust the systems and the platforms that we bring to bear? Well, now as we try to move faster and faster, move at speed to keep up in that OODA loop with the adversary, when you have hypersonic weapons and you have other things going on, how do you build that trust? And when we think about trust, we think about it like Eric talked about with cyber hardening, EW, and this trust autonomy. And one of the key things around trust autonomy is, how do you build that trust over time? And that's really complicated. Like, how do you make sure people trust a software system, because out of the gate, they don't necessarily trust it. So there's ways you have to build, design those systems in terms of how you interact with the users to build that trust. How do you make it understandable how the system came to that recommendation? How do you display things in a way that make it easy for a user to make a decision and trust it? And then when you start building more automation, you start looking at, where does the human go? Are they in the loop? Are they on the loop? So are they in the line of a decision, or are they observing how the autonomy is working and they can insert themselves? And you don't usually jump right to running things autonomy. You're gonna run with a human in the loop, and then they're gonna build trust in what the system was recommending. And then they're gonna move it up to, I'm gonna be on the loop with an easy way to stop. So think like driver's ed, where the teacher can hit the brake or take control of the car, right, very easily, to then I trust these things to work all together, and I'm sort of observing how they're interacting and guiding them from an intent-based perspective. But you can't jump to that end state. So you've got to build systems and do that. And you have to actually make it dialable over time, because you may insert new things that have to take your trust back. If you look at what we've done with systems over the years, even with Aegis, we have the ability to go full automated in a lot of these systems, but we usually don't turn it on. We let the humans stay in control unless we get to a situation where they need to. So we got to build systems where they don't just assume we're going to jump straight to autonomy. They're going to be able to be incrementally moved across depending on what's going on from a threat perspective and the speed needed to react to keep our citizens and our soldiers safe.
It's a great point. You know, trust is important, Eric, but UX is too, user experience. Some people, you know, use the Apple App Store as an analogy here to sort of describe how command and control systems for tomorrow might be modernized, they might be deployed, they might be used to sort of execute big endeavors like JADC2. Is that a fair comparison here?
Well, I think the heart of the App Store model is a good analog. Fundamentally, what we're seeing technologically are we're able to create software in smaller chunks. So if you think about apps on an app store, there's small bits of functionality that are for a specific purpose, and they can be put on a platform, taken off the platform. The second thing is there's redundancy. So the idea that you can create software that if one app or one function isn't working, you can quickly switch over to another function. Most people have multiple map applications, for example, on their iPads or Android tablets. So redundancy is a big key. The second or third thing I would say would be the self-containment. So when I install an app, it generally comes with everything that it needs. And a lot of the technologies that have come out recently, both in terms of microservices, which allow you to create these functions that have all of their components within them, and also the containerization technologies that allow you to deploy these things in a fashion which they'll install and operate and have all the configuration settings fully baked in. And I think also, if we think about building JADC2 as an Uber system of systems, the analogy also kind of fits in some ways. Orchestration. We've seen infrastructure as code become more popular. This idea that we can do things in code that normally would have been done by system administrators. The ability to become much more flexible in how we and where we deploy these type of applications. And yet all the interfaces and that interoperability is kind of worked out ahead of time and within that. So from that perspective, I think the analog fits. I think where the analog probably falls apart is when we talk about the marketplace. You can't build a unified JADC2 with a per transaction model, for example, a cost model. But from the fundamental technology space, I think there's a lot of good things that you can derive from. It's a good analogy.
Derrick, I'd like to talk about building with you around that analogy for a moment. You know, the Department of Defense has to walk and chew gum at the same time here. They're modernizing, but they also need their systems to continue to function and operate. How do you build C2 applications and systems parallel to systems that are in operation right now?
Yeah, thanks, George. That's a great question. And I will touch on some of the things that Eric talked about around microservices. But to be candid, we certainly can't build our way out of this problem. And the reason we can't is because the legacy systems that are out there today, some of which are very monolithic, we just can't turn them off because we have to be able to fight today, right? So there's a lot of modernization language and collateral out there talking about how we're preparing for 2028, which is good. And there are a number of systems that are out there that are a part of that the modernization structure. The thing is, what we need to be able to do is use a microservices approach to build sidecar capabilities, which will allow us to fight next year. Say if we have an ARG conflict in a couple of weeks or months or a year or two from now, we can't wait for modernization of battle management systems or other systems which contribute to the fight. We can't wait for those to be blown away and rebuilt. We have to be able to bridge that gap. And one of the ways that you can do that is by leveraging microservices and some of the advancements in software to be able to take pieces of monolithic systems that may be out today, deconstruct it a bit and figure out where you can target enhanced capabilities that will help the force achieve their mission without turning off that legacy system. And then as you keep building on building more microservices, more sidecar capabilities, it gets to the point where you're safe to be able to cut off a legacy system. So the fundamental premise here is that we have to be able to bridge the gap between the legacy systems, the old with the new. And as advanced threats come down the pike, we have to be able to respond to that. And the way to do that is by having microservices architectures that allow us to be flexible and adapt to emerging threats rather, at the same time of working with the legacy systems that are very much still alive and well across the force.
So the end state, Doug, involves a ton of data, as we've talked about to this point already, feeding this system with lots and lots of data. Let's close this discussion there. How do you envision the acquisition, the processing, the dispensing of data in a future JADC2 system?
Yeah, it's all about data. We're moving from a platform-centric approach to warfare to actually what I would say an information-centric approach for warfare. Data is a key part of it. One of the problems we're seeing though is going back to the military Internet of Things and sensor proliferation is we're going to generate so much data. We don't have the network pipes to get that data back because the pace of data creation is exceeding the pace of innovation in network capacity and bandwidth. Yes, we're seeing tremendous disruption in space and increases, from everything from satellite, things like Starlink and LEO-based communications to fiber, but it's going to be a challenge. And it's going to be even more of a challenge from a warfighter perspective because we know our networks are going to be attacked, whether it's through jamming or through cyber. So it's about information. And you've got this concept of data gravity. So how do you leave the data where it is, but get the information out? And the information's got a much smaller footprint to get across. So when you mentioned at the beginning around this dispersed C2, right? How do you do C2 in pockets everywhere without having to have that centralized command and control to make every decision, but the intent can be out there, commander's intent can be out there, and commanders can have situational awareness. That is where the data processing and sense making at the edge is absolutely critical. And the infrastructure at the edge that Derrick talked about earlier becomes critical. And then we get the information back and we share information across units and across different parts of the multi-domain operations intelligently so they can all operate. I use the analogy when you start thinking around the future of all these systems, how they work together is kind of like those Russian stacking dolls, right? They all fit seamlessly together when you want them to, but they can all interoperate on their own and then be stacked together. And we need all of our systems to work that way so the data and information are flowing back. So then we have to get those algorithms to the edge. How do we deploy them at scale and at speed to stay ahead of our adversaries and then get that information back for the true situation awareness so commanders can make informed decisions. So it's going to be a fascinating time as we look at how we drive that, how we know how we have to maintain infrastructure at the edge, get the algorithms to the edge, and then get the information back is really what we're going to have to go tack to make sure we are successful from this JADC2 perspective. And that's going to include bringing in partner nations and not just the services.
So Erik, you opened us up on this discussion. Give us one of your nuggets of wisdom as we close things out. What's the one thing that you'd like our audience to take away?
Well, I guess at the end of the day, this is all about the warfighter. And anytime that we're thinking about JADC2, we've got to think about at the end of the day, where is all this going to be used and how is it going to be, despite the amount of data that's coming at us, going to be cognitively handled and then used. So I would just say that, as we look at systems in the future and start thinking about how they're going to interface and operate together, I think fundamentally we just need to think at the end of or out at the edge, we're going to have a set of individuals who are trying to deal with a peer or near peer adversary, and we need to make sure that those capabilities work and that they're truly stand up to the kind of things that we're used to every day around the house and how we live. So that's at the end of the day, that's what we have to keep in mind.
Well, Erik, Doug, Derrick, great conversation, quite informational. Just want to thank you for your time.
Thank you. Appreciate
George,
your time
thanks.
with George.
Thanks, George.
And a big thanks to Leidos for supporting this week's event. Thank you, our audience, for being here. More great JADC2 coverage ahead in our next session, JADC2 and the battlefield of tomorrow. For GovExec, I'm George Jackson.